Welcome in, everybody, to a deep dive with us today
Yeah.
into the world of Neil deGrasse Tyson.
I love Neil deGrasse Tyson.
The best.
Yeah.
So today we're going to be pulling some of his most interesting ideas from a StarTalk YouTube interview that he did.
Yo.
And we're going to be talking about everything from wormholes
Yeah.
to AI to
Right.
the nature of nothingness
Okay.
and even the importance of fostering curiosity.
Oh, I like it.
Yeah.
That's going to be fun.
So since this is a recorded interview that we're diving into, we can kind of, take our time unpacking some of these insights and
Yeah.
really just let the conversation flow.
Yeah, absolutely.
So why don't we start with something that I think always captures the imagination,
Okay.
wormholes.
So, yeah.
Have you ever wondered, like, what it would be like to travel through one of these cosmic shortcuts?
I mean, who hasn't, right?
Right.
Like, it's one of those things you see in the movies all the time.
Yeah, exactly.
And you're like, oh, man, like, what would that actually be like?
Yeah.
And Tyson, I think, does a really good job of grounding us in the concept
Okay.
by first, making it clear that a wormhole isn't something that you, like, fall through,
Okay.
like we traditionally think of as a hole.
Like a sinkhole.
Yeah, yeah.
Or,
Or a pothole.
yeah.
Yeah.
So what's a better way to think about it?
Well, he uses this really great analogy of a sphere.
Okay.
So imagine approaching a wormhole from any direction.
Okay.
It's not like a hole in the traditional sense,
Okay.
but it's more like a point in space where every direction leads to the same destination.
Oh, so it's less about traveling through a tunnel and more about just like arriving at a specific point
Yeah.
from any angle?
Yes, exactly.
Oh, that's interesting.
Yeah, and this idea, as mind-bending as it is,
Yeah.
arose from scientists exploring the mathematics of black holes.
Ah, okay.
And it turns out those same equations that describe black holes also allow for the theoretical existence of white holes.
So black holes pull everything in.
Right.
So it would make sense that white holes push everything out. Okay, but then how do wormholes fit into all this?
Well, some physicists theorize that black holes and white holes could be connected by these theoretical tunnels through space-time,
Okay.
wormholes.
So instead of getting crushed in a black hole's singularity,
Right.
you could potentially emerge from a white hole somewhere else in the universe.
Yeah, it's a possibility.
Oh,
I
man.
know.
It's both terrifying and exhilarating at the same time.
It really is.
Yeah.
And it gets even wilder because Tyson shared this anecdote about his appearance in Action Comics,
Yeah.
#14,
Oh, wow.
where he actually helped explain how Superman,
Okay.
as a baby traveling in a spaceship,
Uh-huh.
could have arrived on Earth faster than the speed of light.
Wait, so is he saying that Superman traveled through a wormhole?
It's definitely a possibility,
Okay.
and it highlights how these theoretical concepts
Yeah.
sometimes intersect with popular culture
Yeah.
in some really surprising ways.
That's cool.
But then Tyson also brings it back down to earth with a more humorous take on what wormholes could mean for everyday life.
I am all ears.
So he imagines like this future where your refrigerator
Okay.
is directly connected to the grocery store
Uh-huh.
via a wormhole.
Okay.
So you'd never have to go grocery shopping again.
All right, I'm on board.
Right.
I'm on board with that one.
I know.
Yeah.
Like, who needs...
Nobody wants to go to the grocery store.
No.
Okay, but on a more serious note,
Yeah.
this idea of connecting distant points in space through wormholes raises a really fascinating question
Yeah.
about the nature of reality itself.
Right. And that leads us to another area
Okay.
where Tyson offers his insights.
Okay.
The intersection of science and religion.
Ooh, now this is where I think things can get really interesting.
Yeah.
So have you ever had an experience that felt profoundly religious,
Okay.
even if you aren't religious?
That's a good question.
Yeah.
I think while I might not personally use the label religious, I've definitely experienced moments of awe and wonder when I think about the vastness of the universe.
Yeah.
Yeah.
And Tyson actually kind of echoes that sentiment.
Okay.
He talks about observing the cosmos from remote mountaintops.
Yeah.
And he uses words like awe and majesty to capture that feeling.
Right.
But he hasn't had what he would consider a, like, in quotes, religious experience in the
Yeah.
traditional sense.
Right. And Tyson really argues that a lot of experiences labeled as religious
Okay.
can actually be explained through a scientific understanding.
Okay.
And he often shares the story of his friend Seth MacFarlane,
I believe, yeah.
who very famously missed a flight that tragically crashed. And while some people might say that MacFarlane's survival was divine intervention,
Right.
He attributes it to a possible hangover.
That's classic McFarlane.
It is.
It really is.
But it makes you think about how we often jump to these supernatural explanations
Right.
when there might be perfectly rational or even, humorous ones.
Yeah. Yeah, and Tyson takes it a step further.
Oh.
And he says that when we encounter something seemingly unexplainable, it might not be a miracle, but rather a sign that we've stumbled upon a new law of physics waiting to be discovered.
I like that.
Right.
It changes your perspective.
Yeah, so instead of just being like, oh, it's a miracle,
Right.
you should be asking yourself what new scientific principle is at play here.
Exactly.
I love that.
It encourages curiosity.
Yeah.
Right. Like that desire to understand the world through this lens of scientific inquiry.
Through scientific inquiry, yeah.
Even when we're confronted with things that just don't make sense.
Yeah.
And Tyson, being the pragmatist that he is, even proposes some clever experiments to test these supposed supernatural occurrences.
Oh. Like what?
So, for example, when people report these near-death experiences, and they say, oh, I saw myself from outside my body.
Right.
He suggests putting a hidden message above the patient's bed. And if they can truly leave their body, they should be able to read it.
Oh, that's fascinating.
Yeah.
Use the scientific method to investigate.
Exactly.
And it reminds me of that anecdote he told about the scientists in the early 1900s.
Oh, yeah?
Who tried to X-ray souls leaving bodies at the moment of death.
Yeah, they wanted to, weigh the soul and see if it, left.
It's so crazy.
I know.
But it's a reminder that, this quest to understand the mysteries of life and death, it's been a driving force in human history.
It has.
And as new technologies emerge, they often get applied to these age-old questions.
Yeah.
It's a testament to our curiosity about the universe and our place in it.
Absolutely.
Speaking of mysteries, are you ready to delve into nothingness?
Let's do it.
Okay, this one always bends my mind a little bit.
Yeah, it's a journey into the heart of quantum physics, where even the seemingly empty is teeming with activity.
All right, let's do it.
Okay.
Welcome back.
All right, so last time we left off.
On the edge of nothingness?
Right.
Ready to explore what quantum physics has to say about empty space.
Yes.
It's a concept that really challenges our everyday understanding of reality.
It really does. We tend to think of empty space as well, empty.
Right.
But quantum physics reveals a much more dynamic and complex picture.
So what's actually going on in this so-called empty space?
Well, even a vacuum isn't truly empty.
Okay.
Tiny particles called virtual particles are constantly popping in and out of existence.
What?
It's true. They appear as particle-antiparticle pairs.
Okay.
Exist for a really incredibly brief moment.
Okay.
And then annihilate each other, seemingly returning back to nothing.
Hold on. So even when we remove all matter, all the atoms and subatomic particles that we can think of, there's still this hidden world of activity.
Exactly. And what's even more mind-boggling is a concept that Tyson learned from physicist Brian Greene.
Okay.
You know Brian Greene. So Greene suggests that these virtual particles, which are connected through a phenomenon called quantum entanglement, might actually be linked by tiny wormholes.
Wait, so those tiny wormholes that we were just talking about?
Yeah.
The ones that could theoretically connect distant points in space?
Right.
Could also be the very fabric of space-time itself,
Sure.
woven together by these fleeting virtual particles.
That's the idea.
That is mind-boggling.
It's pretty amazing.
So it suggests that even the seemingly empty regions of the universe are buzzing with activity, connected by this intricate network of minuscule wormholes.
Yeah.
It completely redefines how we think about space and nothingness.
Yeah, it's like realizing the universe is this much more interconnected and dynamic place than we ever imagined.
And it makes you wonder, how much more is there to discover?
Right.
How many layers of reality are hidden beneath the surface of what we can perceive?
It's a humbling thought.
It is.
And it speaks to the power of science.
Yeah.
To reveal these hidden worlds and challenge our assumptions about the nature of reality.
Yeah. And speaking of challenging assumptions, this brings us to another area where Tyson offers his unique perspective. Artificial intelligence.
AI.
In scientific discovery.
It's on topic.
It is. It's both exciting and a bit unsettling.
Yeah.
Especially when we consider its potential to surpass human intelligence.
Right.
So do you think AI can make genuine scientific breakthroughs?
It's a question that sparks a lot of debate.
Yeah.
Tyson acknowledges the immense power of AI as a tool
Okay.
for analyzing data and accelerating discoveries.
Okay.
But he's a little skeptical about its ability to generate truly original ideas.
So AI is great at crunching numbers and spotting patterns, but not so much at coming up with those aha moments.
Yeah, like the creativity.
Yeah, that leads to those groundbreaking discoveries.
Yes.
So it lacks that creativity and real-world experience.
Yeah, at least in its current form.
Yeah. He uses a thought experiment
He does.
to kind of illustrate this point.
Yeah.
It's the one about uploading your brain to the internet.
Yeah. So imagine you upload your entire brain to the internet.
Okay.
Right? Allowing AI to access all your memories and knowledge.
Okay.
But then you go on a trip and you discover a new species of mollusk.
Okay. Yeah.
And you even share this discovery with a colleague through a handwritten letter.
Okay.
AI would have no idea about this new species.
Right.
Because that information wasn't part of the data it was trained on.
So it can only work with what we give it.
Exactly.
It can't go out and have its own experiences.
Right. It can't just like discover something on its own.
That's such a clever way to demonstrate the limitations
of
current AI.
Yeah.
And to further drive this point home, Tyson often challenges AI enthusiasts
He does.
with a question. When will AI invent a new game that surpasses human creations in popularity and complexity?
That's a tough one.
Right.
Yeah.
It's a high bar to clear.
It is.
So while AI excels at tasks like, discovering new planets, by sifting through vast amounts of data, it seems like there's a certain spark of human ingenuity that it hasn't quite captured yet.
Yeah, it's like that special sauce.
Yeah, but Tyson doesn't completely dismiss the potential of AI to make significant contributions to science.
No, he doesn't.
He suggests that quantum computing might be the key to unlocking AI's true potential.
Quantum computing, that's a whole other can of worms.
Yeah.
Right? So quantum computers operate on the principles of quantum mechanics, which allows them to process information in fundamentally different ways than our classical computers. So it opens up the possibility of solving problems that are currently intractable.
Right.
Even for the most powerful supercomputers that we have.
So quantum computing could give AI that boost it needs to make that leap from analyzing data to generating new ideas.
Yeah, like true idea generation.
Yeah.
Not just mimicking what it's been trained on.
Yeah, it's both exhilarating and a little bit daunting.
I know.
To imagine the possibilities.
It is, and it highlights the importance of approaching these advancements with a balance of enthusiasm and caution.
Right.
Like, as we continue to develop these powerful tools, it's crucial to remember that technology is ultimately a reflection of our values and intentions.
That's a powerful point.
It is.
And it leads us back to the theme of fostering curiosity.
Right.
Nurturing that sense of wonder and exploration, not just in children, but in all of us.
In everyone.
Yeah.
It's about cultivating a mindset that embraces lifelong learning, that seeks to understand the world around us.
Yeah.
And approaches challenges with this spirit of inquiry.
And open-mindedness.
And open-mindedness, yes.
We've been through wormholes and nothingness and even AI so far with Neil deGrasse Tyson.
Right.
So now let's bring these like big cosmic concepts back down to Earth.
Okay.
And see how they connect with our everyday lives.
It's all about bridging the gap.
Yeah.
Between these awesome discoveries of science and the practical challenges we face.
Exactly. And Tyson's a huge advocate for scientific literacy.
He is.
Not just for scientists, but for everybody.
Yeah, he believes that understanding the fundamental principles of science is crucial for making informed decisions.
Both personal and collective ones.
Yes.
He often emphasizes the importance of critical thinking.
Yes, that ability to question information.
Yeah.
And evaluate evidence and draw logical conclusions.
Which is so important in today's world.
It really is.
We're bombarded with information.
We are from all sides.
From every direction.
And it can be tough to decipher, what's true and what's not.
Yeah, exactly.
So having that scientific mindset is so valuable.
Yeah.
It encourages us to pause.
Yeah.
And consider the source. Look for evidence-based reasoning.
Yeah.
And be wary of emotionally charged arguments.
Or clickbait headlines.
Yes, exactly.
So it's about asking ourselves, Is this claim supported by facts?
Right.
And if not,
what are the motivations behind it?
Exactly.
Yeah.
And critical thinking isn't just about evaluating information from external sources.
Right.
It's also about being willing to question our own assumptions and biases.
Yes, because we all have preconceived notions
We do.
about the world.
And a scientific approach encourages us to examine those beliefs.
Yes.
Test them against evidence and be open to the possibility that we could be wrong.
Be open to being wrong?
Yeah.
Yeah, it's about embracing humility.
And acknowledging there's always more to learn.
Absolutely.
And this applies to everything from personal decisions to political debates to global challenges like climate change.
Yeah. Tyson actually uses climate change as a great example of why scientific literacy is so important.
Because it's such a complex issue.
It is.
With far-reaching consequences.
Absolutely. And understanding the science behind it
Yeah.
is key for making informed decisions.
About how to address it.
Yeah.
And he's very clear that denying the overwhelming scientific consensus on climate change is not only wrong, but dangerous.
It is.
As it hinders our ability to take meaningful action.
Right. And this brings us back to that idea of curiosity.
Yeah.
Tyson believes that nurturing that sense of wonder and exploration is essential for everyone.
Not just kids.
Not just kids. Everybody.
It's about maintaining that open mind.
Right.
A willingness to learn.
Yeah.
And a passion for understanding the world.
Absolutely.
And it's that spirit of inquiry that has driven human progress for centuries.
It has.
And it's what will continue to shape our future.
Exactly. So we've covered a lot in this deep dive.
We have.
From the vastness of wormholes to AI.
To the importance of critical thinking.
What resonated most with you?
Yeah, what sparked your curiosity?
Hold on to those thoughts.
Okay.
Because Neil deGrasse Tyson often leaves his audiences with this question.
Okay.
What is the next question that comes to mind?
Ooh.
Let that question be your guide.
Yeah.
Let it spark your own journey.
Of exploration.
Of exploration and discovery.
The universe is vast and mysterious.
It is.
There's always more to learn.
Always.
Keep looking up. Keep asking questions.
Yeah.
And never lose that sense of wonder.
Thanks for joining us for this deep dive.
And we'll see you next time.